Alright, so this video is a simulation, a test of what should happen when you take off from the surface of a spherical world with a radius kind of similar to that of the Earth. What happens to the horizon, what you should see. This is to help me understand what should happen in this situation, so that next time I get on a plane and I look out the window, I'll be able to have some idea as to whether what I'm seeing corresponds to the model that I've always had of my world, which is that of a sphere with a radius of about 6,300 kilometers, or whether what I see tells me that something else is the case. Because that is an incredibly interesting debate that has been happening on the internet for quite a while now, and I love thinking about these kind of things and testing my world and testing my knowledge and testing my models, because usually what I find is I've got completely the wrong end of the stick and totally misunderstood what's happening around me, and I have no idea usually how to even test these things. So I've been thinking for a long time, how on earth do I tell whether the horizon is falling or staying level, and whether what I see should happen or not? And I thought about, do I have to get some kind of graphic design software or something like that that is going to so that I can build a sphere and then somehow put a person in it or a camera in it and then raise it up certain numbers of meters or feet. This is very complicated. I have not got the technical skill to do that. But then I thought, well, hold on, I've got some tools around me. So one of these tools is this game. This is a game called Elite Dangerous. It's a space game. It's a really fantastic space game. If you like space games, seriously play this. It's brilliant. The reason I'm using this is because the developer's gone to great pains to make an accurate one-to-one scale depiction of space, worlds and things, using all of the models that we have that make up our general understanding of the world around us, the solar system, the galaxy, etc., the universe that we're in. Gravity and everything simulated as we understand it. So that makes it really useful for me, because I have real difficulty visualizing what I should be seeing on a sphere the size that we are led to believe that we are on. So I can't even test it. Alright, so this is me looking around. This is the world, look, sky, okay, me chatting to somebody. There we go, that's the world. Okay, so I'm going to show you why I've picked this planet thing that I'm sat on. So this is the map of the system, this is the planet that I'm on. There's the sun and all the other planets. Okay, so I'm going to zoom into this. That's the planet, that's me there, somewhere near the South Pole. Pick this bit because the sun is just there, and that will give me a visual cue. If I'm getting higher and higher and the horizon is dropping, I should see basically it look like the sun's rising even though I'm not moving forward. If it always looks the way it does now, then I've got to think again about what it means to live on a spherical world, because I don't understand. That's what I think should happen from here. Okay, so back into the system, and I'll just show you the information for this. Well, why I picked this one in particular, just because it was the thing nearest me I could find that was this is the most important bit, that was similar to the size of the Earth. So the Earth's radius is 6,300 kilometers, this is 6,900 kilometers, nearly 7,000. So it's close-ish, it's a little bit bigger, but it's close-ish. And there's like 400 billion stars and God knows how many worlds in this game, and I just couldn't be bothered to troll around all of them and find one exactly the same size as Earth. You might say, isn't Earth on it, why can't you land on that? Well, at the minute they haven't implemented landing on planets with atmospheres in this game, so I have to find a rocky world with no atmosphere that's the same size. This is the best I could do, so there we go. Alright, so just a little bit about what we're seeing. Ahead of us we have a military kind of style heads-up display, which has got an artificial horizon. It's got pitch up and pitch down indicators, so if you look at the centre of the screen where it says ship secured, hold W to launch, either side of that there's a orange line with 0. That's the artificial horizon. I'm slightly at an angle because I've parked on a bit of a hill. I'm not very good at parking yet. Um, Above that, you can see there is number 2, and it's in kind of a hollow arrow that's on either side. That is because I'm parked on a hill, my nose is pointing up 2 degrees compared to the absolute flat horizon. Below that, go into minus numbers. Okay. To the right of the horizon and pitch attitude indicator is altitude. You can see at the bottom it says surf 0 meters. That's me. I'm on a surface. I'm at 0 meters. Goes up, and so far it goes up to 2 kilometers. It's dynamic. It scales. It can go quite a lot higher. I'm also going to take visual cues where I can, and I think this might be the best way to do this if I was in a plane, because I'm not going to have lovely calibrated gradations like that. What I'm going to have is the plane around me and me looking out the window. So I might be able to use things like the seat next to me or the seat on the other side of the aisle that's in front of a window. And on this one I've got the headrest, so that might be useful. On this side I haven't really got a lot that's useful. I've got the bar there, but that's not very useful. Also I've got consoles and stuff on that one. Excuse me a sec, I'm just going to cough. Alright, hopefully I didn't deafen you. Okay, so using those visual cues, now at the minute I'm on a hill, so this is not very accurate. I'm at 0 meters. I am going to go up a bit. That's me just setting my engines up so go up fast. I'm going to go up a bit to maybe 100 or 200 meters just to see what it looks like from quite level. So this is me spooling up my engines and going up. Alright, so there we go. That's me just getting above the hills. The rest up there is at 300 meters, and you can see on the altitude there. Alright, so just a little bit of info. I'm going to raise my landing gear because they're annoying. Okay, so looking around me I can see there's generally a horizon. That horizon is at 0. A little bit about the flight model. I've got flight assist engaged. That means my plane, spaceship, whatever, is going to naturally keep to straight and level. So if I push down to minus 11 degrees, I let go of the stick and it just naturally writes itself up to 0, complete level with the artificial horizon. That's parallel to the ground below me. If I pull back on the stick and then I let go, same thing happens, goes back down, writes itself to 0. Okay, I'm showing you that so that you know that there's not some weird thing happening with the horizon. I'm not going to be going forward at all. I'm just going to show you what happens if I go forward. You'll see on the bottom of the screen, center a little bit to the right, that's me pushing forward on the throttle, and you can see those numbers going up. That's my speed. That's in meters per second. I'll throttle back and we'll stop that. I'll wait until I get back to 0. Okay, so I'm not going to be using that at all. I'm just going to be using the vertical, going straight up in a straight line. So let's look over to my right. Okay, so now I don't know if this is because there's still some hills in the distance raising the horizon slightly artificially, but the horizon is basically at the top of the headrest of the seat opposite me. 0 degrees there, follow that line around, there we go. In fact, look, if I get this angle, we can see everything that's happening. You can see my speed, you can see the horizon, and you can see my altitude. Alright, so I'm going to go up to 2 kilometers. That's me going up, look. And we'll just see what happens visually. Now I can see if I look over to the headrest, okay, the ground is going down. That could be at the minute, because I'm only at 900 meters, maybe that's hills. That could be hills. Let's get up to 2 kilometers. Now you can see I'm going up fast, right? 100 meters per second. That's fast. I'm just trying to level off somewhere around there. Okay, 2 kilometers up. Okay, interesting. So 2 kilometers up on this world, and already the horizon looks like it's dropped just over a degree. If I push my stick forward, that's minus 1 degree there, that's minus 2 degrees there. Okay, so we'll go back to level, and if I look over to my right, 2,000 meters, and the horizon is just a little bit below the top of that headrest. Now, the horizon is not level, there are definitely hills there, so that could be making that artificially higher, but it's interesting that it's already dropped. Aircraft that we fly in go to 35,000 feet. It's because I'm in the UK and we use proper units of measurement, not your weird foreign Frenchy ones. In meters, in kilometers, that's about 10 kilometers up. 9, 10, something like that. Okay, so what looks like rain there, that's just this game, because it's really hard when you've got space just around you and nothing to know whether you're moving at all. They've put in pretendy bits of dust. That's me looking up. And it looks like vertical rain, but that's just because there's little bits of dust and I'm going up. So I'm at 6 kilometers. It's already got quite a lot lower in it, and there's more of the sun. 7 kilometers. 8 kilometers. I'm going to get up to about 10 kilometers because that's about probably how high a plane is going to get. Alright, there we go. Just over 10 kilometers. Alright. So, if I was on a plane flying at this height and I looked and compared to ground level, it looks like the horizon is lower. Using the visual cues of what's inside me, so look at that headrest, the ground is lower than it was at 2 kilometers. Noticeably lower. Yeah, okay, it could be hills and stuff have disappeared, but if I look straight ahead and I push my stick down, look, we're at 3 degrees of depression on the horizon and there's much more of the sun visible. So that's interesting, but that's only 10 kilometers. Is that enough to see a dip? Well, I'm going to carry on going up. The reason I'm doing that is, as well as there being plenty of footage and people going on planes a lot, another thing that happens quite a lot is weather balloons and balloon experiments are being used. They have cameras on, and those cameras take images. They go around about up to like what, 150, 170,000 feet. If it's a good one, that's about 30 kilometers up. So I'm going to go up to about 30 kilometers. Look, you can see I'm looking straight ahead. I haven't touched the pitch up and down. You can see what happens when I moved it. You can see I'm not moving it. It's on zero. The horizon is falling away. We're at 15 kilometers, 16 kilometers now, and it's at about 4 degrees. I wonder if it will get down to about 5 degrees by the time we get to 30. It might. And looking over to my right, the ground is definitely, compared to the inside, my visual cues of inside the aircraft, definitely the horizon is falling away. It's going lower and lower. I'm going to get up to 30,000. I'm going to prove to you as well that that's not an effect because I am tilting, I'm rolling the aircraft away from the horizon more towards it. Okay, I'm not at all, it's flat and level, and I'll show you what happens when I do that in a little bit. Alright, 25 kilometers nearly, and we're almost at minus 5 degrees of depression, and there's a lot of the horizon and there's a lot more sun visible. Pretty cool. Definite falling away of the horizon there. Alright, 28 kilometers, we'll just get it up to around about 30, maybe just a little over. It's also a very pretty game, so if you like games that are pretty, and if you like space games generally, honestly I cannot recommend this highly enough. Where are we? Oh, 31 kilometers. Let's throttle that back down, there we go. Alright, so because of flight assist, the plane wants to just hover at exactly resting level. Okay, so we are at 32 kilometers. There is just over 5 degrees of depression. That's me pushing forward on the stick to the horizon there. Let go of the stick and it will go back up. Alright, now this, it looks like there's a slight bow into the surface, the horizon that's visible to me. Field of view and stuff can be weird, and field of view in games can be weird, and lensing, fisheye lensing, etc. If I look out to the right, the ground is much lower than the cues I had at 2 kilometers. Much, much, much lower. Okay, I'm going to show you what happens if I roll the aircraft. So I'm going to roll over to my right. It's me rolling. That's what that looks like. I let go of the stick and the aircraft is going to slowly right itself to straight and level because of the assist. So let me turn over to the right. So that's me tilting. So that is something that could cause the horizon to go up and down compared to the inside, the visual cues you've got inside the aircraft. If there's a roll happening, that's straight and level. I'm going to roll away from the horizon. And it looks like the horizon falls off. Then we go back to straight and level. So this gives me confidence, visual references to say that if I am in an aircraft and I'm flying at about 9 or 10 kilometers, if I take a marker of where the horizon is visually compared to what I'm looking out the window compared to what's inside the aircraft, some cues, maybe even make a little mark on the window myself at ground level, and then I'll go up to 9 or 10 kilometers in height, and I know the aircraft is straight and level, and I'm pretty sure you can tell if your aircraft is tilting over to the right or to the left, because you're going to feel on a slant. And if you've got a glass of water in front of you, if that water is straight and level, you know you're straight and level. If that water starts looking like the ground does here, then you know it'll look exactly opposite that, you'll know you're tilted. So there we go. Alright, that is my little visual demonstration to myself to compare that to aircraft footage and my own experience of aircraft flight. From what I've experienced in life so far, when I'm flying on a plane, I haven't noticed the horizon dropping like that. It won't be as bad as this because we're at 30 kilometers, we're 3 times the height. We're at around 100,000 feet. So I'll go back down to about 10 kilometers, take the visual cues, then go back down to 1-2 kilometers. See that in reverse. You might have seen enough by now. You might think I'm completely bonkers and totally wasting my time. I find this really interesting. I never ever question the world around me, my knowledge, how I've been educated, what my assumptions that I make about the world, because I'm just assuming all the time, yeah, it's a ball. I know it's a ball, everything that I know in science and tells me it is, and we just know it is. But I've never checked. I know from going up and down on hills that the horizon always reaches my eye level. But then that's because my altitude's not really changing that much. I'm not going 10,000 feet. 10,000 feet, 10 kilometers, 10,000 meters. I'm not a mountain climber. If you know anybody who's a mountain climber, you've gone up a mountain that's 2 or 3 or 4 or 5 kilometers, and you've got some way, because to do it just visually is going to be hard because you're only talking a couple of degrees. If you can see that the horizon is 2 or 3 degrees lower than eye level, and you can measure that, then great. That's brilliant. That is rock solid proof of the geometry of the world you're on. If you get up that high and it's not depressed 2 or 3 degrees, you have to think again about the geometry of the world we're living on, and that is pretty crazy. So there we go, now we're nearly down to 11 kilometers. Let's get down to 10 kilometers. We're going to go well below because I've totally forgotten that gravity pulls you down in this game, and I needed to counter it with vertical thrust, and my vertical thrusters are not very strong. So there we go, we're going to end up about 7.5 kilometers probably. I just remembered if you have your landing gear out, you go much slower.
Landing gear deployed.
Okay, so here we are, look, 6.8 kilometers, that's where the horizon is. Let's go down to 2 or 1.5, and we'll see where it is. Look how much difference that has made there. We've gone from below more than 5 degrees of depression of the horizon. We're at 5 kilometers now, it's at 2 degrees. So that's... come back. No, it's not going to do it. Okay. Alright, so, yeah, sorry, 5 kilometers is around about 20,000 feet. look how much that horizon's raising. Now you're starting to see a little bit of topology. Look, seeing hills and stuff in the distance, which are artificially raising the horizon a little bit at 2.5 kilometers. That's just the wonkiness of the world around me. So that makes that hard to tell. But at 2 kilometers, if we look ahead, even though there's a little bit of a rising hill, it's not making that much difference. If I look ahead at those lines, then somewhere the horizon is just about 1.5 degrees. If I look over here, it's at about the top. So if you compare that to what it looked like at 10 kilometers, that's 8 kilometers difference. That's definitely a noticeable difference. Cool. Alright, I'm going to land again. And then we're going to go and plan a plane journey. And let's see what we can see. Laters.
Scan detected.